So we're going to continue finishing example 2 from the last video. So let's write our third row. We've got 0, 3, 1, 0, and we're going to subtract from that 0. Well, 1 times 3 is 3. Negative 3 times 3 is negative 9. Negative 10 times 3 is negative 30. So if we do that subtraction, we're going to end up with 0, 0. 1 minus negative 9 is like 1 plus 9, so 10. 0 minus negative 30 is going to be 30. So our current matrix looks like 1, negative 1, 4, 6, 0, 1, negative 3, negative 10, and 0, 0, 10, 30. So all I'm going to do to move on to the next iteration, the next version of this matrix, is I'm going to take R3, and I'm going to have to do this on another page, divided by 10 to get a new third row. So if I took that third row and divided it by 10, I would end up with the matrix 1, negative 1, 4, 6, 0, 1, negative 3, negative 10, 0, 0, 1, 3. So as a system, that means we have x minus y plus 4z equals 6. We have y minus 3z equals negative 10, and z is equal to 3. So in our solution, we know the z term is 3. We're going to take that and put it into the second equation. So we're going to go y minus 3 times 3 equals negative 10. Well, 3 times negative 3, we're going to get y minus 9 equals negative 10. So if we add 9, negative 10 plus 9 gives us y equals 1. So our y term is 1. And then we're going to take the z and the y and plug them in to that first equation. We're going to have x minus 1 plus 4 times 3 equals 6. 4 times 3 is 12. If I add that to negative 1, I'm going to end up with x plus 11 equals 6. When I minus 11, and actually I noticed I made a mistake, my y should actually be a negative 1, which is going to change some stuff here, especially here in the red. So what's going to change is it's going to be x plus 1, because we're minusing a negative 1, which gives us x plus 13 equals 6. If we subtract 13 from 6, we're going to get x is equal to negative 7. So I think we should do one more example, and then we can call this lesson on Gauss elimination done. So example 3, we're going to have the system 4x minus 4y plus 8z equals 12, and then x minus 2y plus z equals 11, and negative x plus y minus 3z equals negative 1. So first, as an augmented matrix, we're going to have 4, negative 4, 8, 12, then 1, negative 2, 1, 11, and negative 1, 1, negative 3, negative 1. Now, here, I'm actually going to start by doing something to that first row, because we want the leading coefficient of that first row to be a 1. So I'm going to take R1, our first row, and divide it by 4 and replace the first row with that. So now my matrix is going to look like 1, negative 1, 2, 3, and my other rows are still the same. 1, negative 2, 1, 11, negative 1, 1, negative 3, negative 1. So moving forward, what I'm going to do now, and there's a few different things we could do, but I'm going to actually take my second row and subtract my first row from it and replace my second row with that difference. So I'm going to take 1, negative 2, 1, 11, and subtract from that 1, negative 1, 2, 3. So 1 minus 1 is 0. Negative 2 plus 1 is going to give us negative 1. 1 minus 2 is negative 1. And 11 minus 3 is 8. So now my matrix looks like 1, negative 1, 2, 3, 0, negative 1, negative 1, 8, and negative 1, 1, negative 3, negative 1. And really in the next set of operations, I'm going to just take the opposite of my second row and replace that into the second row. Just get rid of the negatives. So I'm going to have 1, negative 1, 2, 3, 0, 1, 1, negative 8, and negative 1, 1, negative 3, negative 1. Now moving into the next operation, I'm going to take my third row, because my first two rows are how I want them to be. I'm going to add to it my first row. And that's going to give me a new version of my third row. So I'm going to go negative 1, 1, negative 3, negative 1. Lots of numbers to list. 1, negative 1, 2, 3. And we're adding these. So we're going to get 0. 1 plus negative 1 is 0. Negative 3 plus 2 is negative 1. Negative 1 plus 3 is 2. So we're actually almost there. We're going to have 1, negative 1, 2, 3, 0, 1, 1, negative 8, 0, 0, negative 1, 2. Really, all we have to do now is take the opposite of R3 to get our third row. So when we do that, we're going to have 1, negative 1, 2, 3, 0, 1, 1, negative 8, 0, 0, 1, negative 2. So now I'm going to come up with a new page, and I'm going to just take that last matrix on it. So as a system, we can write this as x minus y plus 2z equals 3. Y plus z is equal to negative 8, and z is equal to negative 2. So we know for our solution set, our z term is negative 2. I'm going to now plug that in. So y minus 2 is equal to negative 8. If we add 2, we find y is equal to negative 6. So we've got our y part. And now we're going to go x plus 6. 2 times negative 2 is negative 4, so minus 4 equals 3. So we're going to have x plus 2 equals 3, which means x is equal to 1. So our solution is 1, negative 6, negative 2. And we're going to wrap up this lesson on Gauss elimination.